Is it ever going to ding? It dinged for you? Oh, no. Well, it's not dinging for me. There it goes. Oh, man, I'm going to have that first like 5 minutes of me doing nothing, huh? Oh, well. All right, let's go into this problem right here. So we got to the difficult part of this, I'd say at the beginning, was probably being overwhelmed at trying to separate all your x's, right? So these guys right here, these are all my x terms right here, to get them on one side, and then get all my y's on the other side, this y term right here. So what I did was just started moving things around, right? I started off by moving this entire term right here from the left side to the right side. And then, since there's no more pluses or minuses, right, it's just a single term equaling to another single term, we could multiply and divide, and we can move things over from one side to the other. So so I rewrote this right here, e to the negative x squared, as e to the x squared in the denominator. I cross multiplied it to the numerator over here, so it has the x term on this side. And then this y term, I divided by it to both sides, so I can get rid of the y on that side. And that's how I separated my x's and y's, right? And I told you guys before, that is worth a point on a free response question. If you can show them that you know how to separate variables, that's just algebra skills, you can get a point on your free response question, which we talked about, right? The average score for a 9-point problem is like sometimes 2 to 3 points, which is a little ridiculous, but getting 1 point is a big deal. And if you can just do some algebra just to separate your variables, you can get that point very easily. Now, the next point that you can get is if you integrate correctly, right? If you can integrate both sides correctly. Now, this right here was a little bit difficult, a little bit rough to look at, but one trick is if you have a fraction like this, and it's only a single term in the denominator, one trick you can do is try to split up your fraction, right? So y squared over y minus 1 over y is another way I can write this. And the reason why I want to split that up is because y squared over y, that's just y, and the integral of y is very easy to do. 1 over y is the same thing as y to the negative 1, or you could leave it as 1 over y as well, because you know the integral of 1 over y, thanks to your quiz today, right? That's going to be the same thing as ln, right? It's going to be the same thing as ln. Okay, so this left side is ready to be integrated. This right side, on the other hand, has x times e to the x squared. I have no idea what the integral of e to the x squared is going to be, right? So, and also, there's an x right here. I don't know what the original function should have been to get this function multiplied by another function. So I'm going to try a technique, and it's the only technique we've learned, and it's the only technique that you'll need to know for, well, it's not the only technique. It's one of the techniques you'll need to, I shouldn't say it that way, but it's a technique that we're going to try to see if it's going to work out for us, right? And that's the use substitution technique, right? I'm going to go in here and use use sub, and I'm going to let u equal to, and I'm going to look at this right here. Doesn't x look like it's a derivative of x squared? Does it not? I think x does look like it's a derivative of x squared, right? It's a factor of the derivative of that, right? It's a form of it. So I'm going to let u equal to the non-derivative form of that, which is going to be x squared. I'm going to let u equal to x squared. All right, now how did I know that that's the case? It's just from practice. I've done this so many times that I kind of know which ones to do. How's that going to be for you guys? You just try it. If it doesn't work out, that's okay. That's one thing that you guys need to get over, is being okay with the fact that something you try isn't going to work the first time, right? You just try it. And I know that sounds weird, but you try it enough times, you'll eventually see like there's a, I don't know how to explain it. You'll just get better at figuring out which one needs to be done. It just comes from the practice of doing these problems. So anyways, we're going to go ahead and let u equal to x squared. I'm going to go ahead and take the derivative of both sides. I end up with du is equal to 2x dx. Solve for the dx, right? Dividing by 2x over here. So I ended up with du over 2x is equal to dx. So I can replace this dx right here with du over 2x. And I can replace the x squared with u, right? with u. So I can rewrite this right here. This is going to be negative the integral of x e to the u, and then replace the dx with du over 2x. You'll notice that you've done this correctly because what do you see about the x's right there? This x right here and this 2x is going to cancel out, right? So this over here is going to be equal to negative the integral. This is going to be 1/2. I'm going to write that 1/2 in front. Negative 1/2 times the integral of e to the u du, which hopefully you guys know the integral of e to the u is just going to be e to the u. The integral of e to the single term is just going to be e to that single term. If it was e to the 2x, it gets a little bit more complicated, so you have to do a little bit of use substitution there. And we'll practice more on that. But integral of e to the anything, right, as long as it's a single power, it's not 2u or 3u or u squared or u to the 5th, it's just u. It's just going to be 1/2 e to the u. Don't forget the plus c. And that's integrated, right? That's integrated. All you got to do now is replace the u with what it was originally, which is going to be right here. It can be negative 1/2 e to the x squared plus c. And that's done on the right-hand side. I've done the integral using my x's, and I got that right there. That is my integral right there. So the next thing I have to do now is do the integral of my y's here. The integral of y is going to be y squared using the power rule divided by 2. The integral of 1 over y is going to give me minus the natural log of y. Now, I didn't talk about this before, but when you do the integral of 1 over y, I should have specified this before. It is the derivative of ln of y, we talked about this, right, is going to be 1 over y. But when we do the integral of it, when we do the antiderivative of it, we have to include that y in absolute values. Because sometimes when you do the integral of something, you have a negative function that comes through. And natural log doesn't work very well with negative numbers. Natural log only works with numbers that are greater than 0. So we put the absolute values there to kind of catch that there. Natural log also doesn't work very well with 0, but that's okay because y can't equal to 0 because then the function would be non-existent at that point, right? Because you get an error. Okay, so I've done all this work and I have this now as my integral. I, of course, should not forget my plus c, but the plus c is already included on the other side. Now, if this was a free response question, right, and you did this integral up to here, this is your second point. You don't have to solve it all the way for y unless they specify it, right? You can go ahead and get to here, and you've got your second point. There's one more point you need, and that one more point that you need is to find out what the plus c is. Now, in the last class, right, we would stop here, and we got our answer with our plus c right here. That's perfectly fine. But that's because there's no initial condition, right? This one had no initial condition, right? But this one does have an initial condition. The initial condition is y of 0 is equal to 1, which means x is equal to 0 and y is equal to 1. That's our initial condition. With that initial condition, we're able to actually find out what c is by plugging in these values, right, into our general solution right here. So I know that x, when x is equal to 0, y is equal to 1, I can just plug in those values and find out what c is, right? So wherever I have a y, I plug in 1. So this would be 1 squared over 2 minus the natural log of 1 is equal to negative 1/2 e to the 0 squared plus c. And that's pretty much it. We work this way through, and we have here 1 squared over 2 is going to be 1/2. The natural log of 1, if you don't know it, is equal to 0. It's one of those ones that you just kind of need to know. Log and natural log both have that. Actually, I don't know about log, but turn on your calculator, knock me. The natural log of 1, right, is just equal to 0. So that's going to go away, right? And this, of course, is equal to e to the 0. E to the 0 is just 1. So this would be negative 1/2 times 1, which is just negative 1/2 plus c. So to find out what c is, I just need to add the 1/2 to both sides. 1/2 plus 1/2 is 1. That tells me that c is equal to 1. Now that I have c is equal to 1, I can just go back to this equation right here and replace out my c with 1. So this right here is going to become y squared over 2 minus the natural log of the absolute value of y is equal to negative 1/2 e to the x squared plus 1. And there you go. That's your particular solution. You got your plus 1 as your c, and that specify exactly where your graph is going to land on your, if you were sketching a slope field. You actually have your answer now. And it is going to be going through that particular point. Is that all right? It's a lot. I kind of just rushed into this problem where we kind of left off on this monstrosity of a thing there. But hopefully that's okay. This next part, how good is your algebra skills, guys? How good is your algebra skills? Decent? You're technically not done in a sense that you're supposed to solve for y. And if you're looking at this problem, it gets a little bit tricky, right? Where you have to solve for y. So I'm going to put that on hold for right now, which, you know, we can do, but I feel like it's going to be a lot of time just to show what it's going to become. But I don't know. Maybe I'll do it on a separate video and you guys can watch that. Or actually stop by during office hours. I can show you how to solve this one for y. Or you can try it yourself. Yes, I can show you. You can try it on your own and then stop by during office hours to see if you got the right answer or not. Because it's not fun. that one is not fun. That one is actually kind of troublesome. But yeah, give me a second here. Yeah. I don't think that one's going to be easy to solve for y, honestly, just because there's a y squared and the ln of y. Actually, no, don't try to simplify that. I don't know about that one, because then you got to square root to get that y out of there, and to square root, and then you have to deal with the ln of y. I'm just going to leave it here. Whoop. We'll just leave it there. All right. That being said, let's take a look at an easier problem for you guys to try, right? That's not as complicated as that. So let's try another problem, and then let's have you guys try it out. Okay? So let's do an easier problem, and let's see if we can do it piece by piece. And if you feel like you can do it on your own, go ahead and do it on your own. Okay? So let's go here. Let's say I was given, right? Let's say I was given dy dx is equal to 9x squared minus 8x plus 7. Yeah, ignore that last one. Let's just leave it at that. Let's say that one was good enough. Let's take a look at this problem. All right, we have this right here, and they tell us that there's an initial condition. And that initial condition is that when x is equal to 1, y is equal to 3. All right, so we got that right there. Now, can you guys take a second right now and see if you can earn your first point? Can you separate your y's and your x's on there? I'll give you guys about 10 seconds. Try that out. Actually, yeah, we got like 5 minutes. So yeah, try it right now. So see if you can separate it. And if you're watching a video of this, try pausing the video and just see if you know what to do to separate your x's and your y's. This one's actually not as difficult as the other one. It's far less difficult. Now, if you come across this and they ask you to solve this, I didn't actually give directions on this here. There should have been more directions. Given this, I need you to find y. That should have been the directions there. No, I mean, geez. Okay, so to do this, right, this differential equation, if I'm looking for y, all I have to do is move the dx over. So if you were able to do this, dy is equal to 9x squared minus 8x plus 7 times dx. If you're able to write this down, you would have earned a point on a free response question on the AP exam. That's all it's asking you to do when you're solving differential equations. And this is a differential equation. If they ever give you a derivative, it could be dy dx, it could be y prime, right? It could be written as f prime of x, any type of derivative that they're giving you, and they're asking you to find the original function. It's a differential equation, and you're dealing with integrals to get there, right? So once you get to here, the next thing you need to do now is take the integral of both sides. The integral of dy is just going to be y plus c, of course, but I'm not going to write that plus c there. The integral on this side, I have a bunch of pluses and minuses. This is just a chain rule in action, isn't it? Right? This is just a chain rule in action. So 9x squared is the same thing as 9 times x cubed over 3, right? Because that's the antiderivative of x squared is x cubed over 3. That's going to simplify. Minus 8 times the integral of x squared over 2, right? Again, power rule, right? This is x to the first. That's going to become x to the second over 2. This was x to the second, became x to the third over 3. Plus 7x. That one's just straightforward, right? The derivative of 7x is just 7, right? And this, of course, don't forget the plus c at the end, right? Simplify everything out. I have here y is equal to 9 divided by 3 is going to be 3x cubed minus 8 divided by 2 is going to be 4x squared plus 7x plus c. Take a second when you get to here and double check that your integral is done correctly by taking the derivative of this. Do it off on the side somewhere. Do it off on the side somewhere, right? Do it off on the side. Here's my side. Take the derivative of 3x squared. The derivative of 3x squared is 3x cubed is 9x squared. Minus derivative of 4x squared is going to be 8x. Plus the derivative of 7x is going to be 7. So that right there matches my original problem. So I've done the integral correctly. This is a practice that most people overlook because they'll say, like, of course I did that integral correctly. But once you get to the more difficult ones like cosecant, sine, tangent, square root functions, 1 over x's, do it on the side. Practice, practice, practice. I can't stress that enough. This one, even though it was simple, I still did it just to check it. Okay? Oh, derivative of a constant is just 0, which is going to be a plus 0 that follows at the end there. This is perfect. Now, to find, this is not my full answer. This right here, this is just a general solution. What we need to find is if we have an initial condition, we're looking for this thing called a particular solution. Particular solution. And to get that particular solution, all you got to do now is plug in your x and your y and solve for c. And I'm out of time. It is 10:14. So you guys can go ahead and plug in your x is equal to 1, your y is equal to 3. You should get a constant that is a negative number. And I'm going to leave you guys to try that on your own there. And then once you get your constant, you plug that in for c. And then you'll be done with your answer. And you should end up with y is equal to 3x cubed minus 4x squared plus 7 minus whatever that constant is after you plug in those numbers in there to get that. But yeah, have a good rest of your day, guys. Have a good rest of your week. I will see y'all on Tuesday. I do have tutoring today, but at 3 o'clock to 4 o'clock. No one signed up for it, but if you guys want to, the sign up's still open if you guys want to show up today at 3. Other than that, have a nice day. I'll see everybody later. Sign up for tutoring anytime this week, guys. Tuesday through Friday if you want to come in person. I'll be here in person at school. All right. Bye, everybody. Woo. So long. Oops. Let me end the recording.